channel. I'm back. My student, my followers, my subscribers. Nice to meet you. Yesterday we have seen about divisibility test, how we test whether a certain number is divisible by 2, how we test whether it is divisible by 3, 4, 5, 6, 8, 9, and 10. So that was our yesterday's topic. We test the divisibility test of numbers. Today we are going to see the prime factorization, how we factorize certain composite number with the prime factorization. So this is, by the way, this math is it is taken from grade 9 mathematical unit 2 from the numbers system. So let's go on what does it mean when you say prime factorization. What does it mean, prime factorization? Prime factorization means the expression of the composite number as a product of prime number. My beautiful student, we have seen that what does it mean the prime number, what does it mean composite number. You have to know this first. Prime numbers means a numbers who have two distinct unique factor, that is one and itself. For example, when we say 2 is prime number, why? It has exactly two distinct factor, which is 1 and 2 itself. What about 3 also, 5, yes, 7 and 11, 13, 17, 19, 23, like that. Like those numbers, they are called prime numbers. So we have seen that what does it mean prime numbers, what does it mean composite number. Composite number means a number who have more than two factor is called composite numbers. For example, if we take 4, it has 3 factors. The first one is 2, and 4 itself is the factor. So when we come back to our prime factorization, which is our today's topic, does it mean just prime factorization means the expression of composite number as a product of prime number. Expression of composite number as a product of prime number is called prime factorization. For example, let's take example number 1. Yes, let's take example number 1. Just we can take 6, for example. As a definition say, the expression of composite number as a product of prime number. 6 is a composite number because it has more than 2 factor. So 6 means we can explain as a product of prime numbers. For example, 2 is prime number, 3 is prime number. 6 means 2 times 3 is 6. So this is a prime numbers. Another, let's take 9. 9 also we can express as 3 times 3. Yes, both are prime numbers. So we explain as a prime factorization. This does means this is called prime factorization. This is called prime factorization. Let's take another big number. Let's take 30. Let's take 30. To express this 30 as a prime factorization, first you have to divide with, start from small prime numbers. Small prime number is 2. So divided 30 by 2 is 15. Yes. Is the 15 divided by 2? No. So we move on from the 2 to 3. 3 divided by 15 divided by 3 is 5. So these all numbers are what? They are prime numbers. So 30 can be explained as 2 times 3 times 5. Look, as the definition said that prime factorization means expression of composite number as a product of prime numbers. So this is a prime number, this is prime number, this is prime number, this is composite number. So this is how we explain numbers with prime factorization. Let's come to another number. Let's come to another number. For example, let's take 45. Let's take 45. Let's take 45. Is it 45 is divisible by 2? No, it is not divisible by 2. So we move on to 3. It is divisible by 3 because 4 plus 5 is 9. 9 divided by 3 is 3. So it is divisible by 3. 45 divisible by 3 is 15. Yes. Now 15 also divisible by 3. It is 5. So we can explain 45 as 3 times 3 times 3 times 5. 3 times 3 times 5. So this kind of expression is called prime factorization. Prime factorization. Okay, let's take another example. Let's say 21. Okay, 21 is not divisible by 2, so let's move to 3. Is it divisible by 3? Yes. 3, 7. So 21 is explained as 3 times 7. That's very simple. Another example. Let's take 17. Let's take 17. Is it 17 divisible by 2? Yeah. 17 divisible by 2 is 35. 17 divisible by 2 is 35. So 2 is a prime number. So let's move to, is it divisible by 3? No. Divisible by 5? Yeah. How much? 7. So all these numbers are prime. So 70 can be explained as or expressed as 2 times 5 times 7. 2 times 5 times 7. So we can explain 70 as 2 times 5 times 7. This is all about it. Okay, let's come to another example. Please double tap the screen. Okay, sorry. Sorry, what happened? Okay, let's come to another example. Let's take 105. How we explain this 105 as prime factor. So divided by 2, no. By 3, no. Yeah, it is divisible by 3. So divisible by 3, how much? Here it is 3, 5. Yes, divisible by 3, it is 35. Now, is it divisible by 3? No. Divisible by 5? Yeah, it is 7. So we can explain prime factorization of 105 as 3 times 5 times 7. You get it? Yeah, if you get it. If you didn't get it, forget about it. Okay, let's continue, my family. Let's continue. Another example. 200, let's say 52. 252. Is it 252 is divisible by 2? Yeah. How much? 126. Is this 126 is divisible by 2? Yeah. 100 means 50 plus 13 is 50 plus 13 is 63. Yes. Is this divisible by 2? No. Divisible by 3? Yes. By 3, 21. Okay, it is divisible by 3, 7. So this is how prime factorization work. So this 252 can be explained as 2 times 2 times 3 times 3 times 7. Yes, so this kind of expression is called, my student, this kind of expression is called prime factorization. Prime factorization. Why? When we said that, what does it mean, prime factorization? Here we explain what does it mean, prime factorization. Here, the expression of composite number as a product of prime number is called prime factorization. Here, came my student, came here. What is this number? Is it prime or composite? It is composite, always. It is obvious. So this composite number is explained as product of prime number. These all numbers are prime number. So composite number is expressed as a product of prime number. This kind of expression is called prime factorization. Prime factorization, my student. Prime factorization, my student. Yes, this is, don't forget, please. So let's see another example. Let's see another good example. Let's take a big number. Let's take big number. 1848. Let's say this. Okay, my student, come on, my student, come on. How we explain this number in a prime factorization? Come on, my student. First, is it number is divisible by 2? Because we start from 2. Why? 2 is the smallest prime number. Okay, yes, it is divisible by 2. Why? The last number is even number. So since it is the last number is even number, this number can be easily divisible by 2. Okay, divide this by 2. 1000 means 500. 500 plus here 400, 900, here 24. Yes, you get it? Yeah, 924. Okay, come on. Now is it 924 is divisible by 2? Yes, yes, it is divisible by 2. How do I know? This last number is even number, so it is divisible by 2. Divided by 2, 400. Okay, 50 plus 12, 62. So 462 is the last the product. Okay, let's continue. How we explain? Is it 462 is divisible by 2? Yes, again it is divisible by 2. Why? How do I know whether this 462 is divisible by 2? How do I know? Because the last digit is even number. If it is even number, it can be explained or it can be divisible by 2 easily. Okay, so divide this 262 divided by 2, 30. I think 31. Yeah, I think it is 31. Okay, come on, come my beautiful student. Come on, my beautiful student. Why don't you double tap this channel means? Okay, is this divisible by 2? No, this number can't be divisible by 2. Why? The last number is not even number. One is it is not even number, it is odd number, so it is not easily divisible by 2. Okay, my beautiful student. Okay, let's divide it by 3. Is it divisible by 3? Yes, because the summation of these digits 2 plus 3 is 5, 5 plus 1 is 6, 6 is divisible by 3, so this number can be divisible by 3 easily. So when divided by 3, 23 is 7, 21, 77. Yes, 77. Is it divisible by 3? No. Is it divisible by 5? No. Is it divisible by 7? Yes. 11. Look, my beautiful student. Look here. Look this number. 1848 can be explained as yes, 2 times here, 2 times 2 times 2 times 3 times 7 times 7 times 7. Yes, this, just leave it. So 1848 is a composite number and explained as prime factorization of these prime numbers. So this kind of explanation is called prime factorization. Prime factorization is like this. Prime factorization is like this number. Okay, let's take another example. Let's take another example, my beautiful people. Let's take 360. Let's take 360. Sorry, my friend was calling me, so I do that. So let's come to this number. Let's come to this number. 360 divided by 2. 150, 180. Okay, now it is divisible by 2. 19 divisible by 2. 45 divisible by 3. Divisible by 3 is how much? 15 divisible by 3. 5. So we can explain this as 2 times 2 times 2 times 3 times 3 times 5. Yes, my beautiful student. So 360 can be explained or expressed as like this. So this kind of expression is called, my beautiful people, my beautiful student, this number is expressed as prime number. This is a composite number. It is expressed as a prime product. So this kind of expression is called prime factorization. Prime factorization. My beautiful people, prime factorization. Let's come to another 400. Let's come to another example. Okay, my beautiful people, 460 56. Come on, my student. Come on. Double tap. Okay, is this number is divisible by 2? Yes. How do I know? From the yesterday's topic, we test this number. You can test is it divisible by 2 or not by only looking at the last digit. If it is even number, it can be divisible by 2. So this number can be divisible by 2. Divide this 456 divided by 2. How much? 200. Yes, 228, I think. Yeah, 228. Okay, is this number is divisible by 2 again? Yes. Why? This number is even number. Divided by 2, 140. Come on, my people. 140. Is it 140 is divisible by 2? Yes. Why? How do I know? How do I know? This 4 is even number, so it is divisible by 2. So 150. Here 7, 50, 57. Yes, 50 is not 57. I think, yeah. 157 by 2 is 57. Yeah. Okay, come on, my people. 57. Is it number is divisible by 2? No. Why? It is not a it is not even number. The last number is not even number. If it is not even number, it is not divisible by 2. So this is not divisible by 2. Okay, is it the number is divisible by 3? No. Is this number is yeah, it is divisible by 3. How do I know? People? Come on, my student. Here there is an interesting. How do I know this number is whether it is divisible by 3 or not? Come on. Yesterday we said that if we test any number can be divisible by 3 if the summation of each digit is divisible by 3. Sum. Add this number. 5 plus 7 is 12. Is it 12 is divisible by 3? Yes. So this number is divisible by 3. Come on, my people. Divisible by 3. How much? 1, 27, 9. Come on. Come on here. Is it 90 divisible by 3? No. By 5? No. By 7? No. So it is prime factor. So this number is prime. So 456 can be explained as 2 times 2 times 3, 2 times 3 times 19. You get, my people? You get, my student? Yes. You can also explain as to the power of 3 times 3 times 19. You get it? You can explain this as to the power of 3. So this kind of expression is called, my beautiful student, is called this kind of expression is called prime factorization. Prime factorization is called prime factorization. Is called prime factorization, my beautiful people. Okay. Let's take the last example. Let's take the last example, my beautiful student. Today we are talking about the prime factorization. We are talking about prime factorization, how we factorize numbers. Yes, how we can factorize numbers by prime using prime numbers. We are talking about prime factorization. We define that prime factorization means an expression of composite number by product of prime numbers. So using this definition, we have seen a lot of examples. We have seen a lot of concepts. So let's come to another example. Let's take 512. Let's take 512. Yes. Is it 512 is divisible by 2? Yes. Is 256 divisible by 2? 128 divisible by 2. 64 divisible by 2. 32 divisible by 2. 16 divisible by 2. 8 divisible by 2. 4 divisible by 2. 2. Look, 512 can be explained as 1, 2, 3, 4, 5, 6, 7, 8, 9 as 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, or you can explain as to the power of 9. This kind of expression is called prime factorization. Prime factorization. This is all about today's topic. Have a nice time.